Okay, so now here are the rest of the general types of chemical reactions. So this first one is combination reactions, and I think as we progress through the PowerPoint, we'll have these in more detail. Yes. Okay, so this is just the general overall here. So notice we have two elements. Those two elements combine to give us one element. We have a decomposition reaction where we have an element. I say an element. We have a compound, and that compound breaks into the two constituent elements. Okay. We have replacement reactions where we have two elements in an ionic bond, another element, and then the negative ions actually switch places. Or we can have the same thing here, only the positive ions switch places. Okay, so there's things that happen with ion exchange reactions. We have ions of one compound interact with the ions of another compound. So an ion exchange is kind of like a replacement, but it's a little different. And we'll talk about that more here in just a moment. But with ion exchange, we have some results from that, and you will see that, that with ion exchanges we end up precipitating solids, forming gases, or forming water, or a combination of those. So precipitation reactions, lead is a very popular element for precipitation reactions in different salts and compounds, and then you have an ion exchange reaction because it produces very brightly colored precipitates, which were at one time used in paint. So that's where that whole lead-based paint idea came from. Okay, so oxidation reduction reactions. So with this, we have one of our elements oxidizes while the other one is reduced. So when we say reduced, that means we're pulling that oxygen away from it, or it's gaining electrons. Okay, so oxidation is the loss of electrons. So think about the periodic table and the position of oxygen. Okay, so oxygen is over here. It's going to have a tendency to gain 2 electrons. So if something's oxidized, that oxygen is pulling those electrons from it and holding on to them. Okay, so when we reduce that, that particular element gets those electrons back, and then something else oxidizes. Okay, so see what we have here. We have iron oxide, or rust. It's combining with carbon, and whenever those two combine, of course you've got to get the reaction started, and whenever that reaction does start, we end up with 4 pure iron atoms, and then 3 carbon dioxide molecules. Okay, so here's a combination reaction, which synthesis reaction in which 2 or more substances combine to form a single compound. And generally, these are just elements, and those elements react, and they produce a new element, or a new compound. Okay, so here we have iron, we have oxygen, and when those come together, we produce iron oxide. Okay, or again, rust. A decomposition reaction is the opposite. So it's a compound broken down into simpler substances. So we have a compound, and that compound, due to heat or some other input of energy, produces the 2 elements that make up, or I say the 2 elements, but the two products that make this up. Okay, so X, Y splits up into X plus Y. The example I use here is mercury oxide. If we add some heat to mercury oxide, it drives off the oxygen and causes them to separate into pure mercury and then oxygen. Interesting reaction, decomposition reaction you can do yourself. at home is if you have a pot of boiling water, you can put baking soda into it. And you'll notice you get a lot of bubbles, you get a lot of fizz, and that's because that baking soda is splitting into, it's actually breaking down into those simpler substances. So that sodium bicarbonate is changing into, is breaking into two simpler compounds. Okay, we have replacement reactions. So in a replacement reaction, an atom or a polyatomic ion is replaced by a compound, replaced in a compound by a different atom or polyatomic ion. Okay, so they show this little example here. This is copper sulfate. I'm sorry, it's copper chloride. So whenever you put aluminum foil in the copper chloride, the aluminum actually trades places with the copper. So the reactant is the aluminum and the copper chloride. The product is copper and aluminum chloride. Okay, so XY plus Z, notice that Z and the Y trade places. So that would be the aluminum and the copper in this reaction right here. Or the positive part can be replaced. So X plus Y, XY plus A. So notice that X trades places with that A. So the positive ion is replaced in that particular reaction. We have ion exchange reactions. And so this is where ions simply trade places with each other. And that's a function of their electronegativity and other things that cause different ions to have more affinity for other ions. Okay, so a reaction that takes place when ions of one compound interact with the ions of another compound, and then this is where they form a precipitate, a gas, or a water, or a water, where they produce some water. So a neutralization reaction with an acid and a base is a type of ion exchange reaction that produces water. It also produces a gas. So notice here we have AX plus BY turns into AY plus BX. So that X and Y have switched places. Alright, so what we have here is chemical equations where we're showing that atoms are conserved, mass is conserved, and then we have this law of combining volumes. Okay, so gases at the same temperature and pressure contain equal numbers of molecules. Okay, so here we have, what we're showing here is we have hydrogen plus chlorine. Notice we have 2 parts of hydrogen, 2 parts of chlorine. When we put those together, we end up with 2 parts hydrochloric acid. Okay, so down here we have H2, and then O2. And when these combine, we're going to end up with 2 parts of H2O, vapor. Okay, so we have the same number of molecules. Okay. Alright, so units of measurement used with the equations. So we have the atomic mass unit, which is 1/12, the mass of a carbon-12 atom. We have a unit called the mole, which is a number, just a specific number of atoms, and that mole is 6.02 times 10 to the 23rd. That's called Avogadro's number. And it's important because it relates to what we call the molar mass and the I think the molar gram mass. We'll look at that here more in a moment. Okay, but essentially, if we have 1 mole of carbon-12, then we have a mass of 12 grams. Okay, so if we had 1 mole of hydrogen, we're going to have 1 gram of hydrogen, and so on and so forth. We'll examine that more here in just a moment. Okay, so I am going to end this one here, and then we'll pick back up in the next one.